All right, so this is the quality of service video. So the topic of this one is quality of service. And what we're talking about here is how good is your connection. Usually this is link by link, and we'll talk about this in a minute, the overall sort of how good your overall connection is. But this is just sort of the basics of it. So right now I've had the same connection from Cox, by the way, for years and years and years, and it's always the cheapest one. When we started out, the price was $14.99 a month, and we got 1 megabit per second. Over time, it's just been upgraded, not by my wish. Because honestly, for a while, we were on 3 megabits, and that was fine. Right now, we're at 10 megabits per second. I'm paying $45 a month. Now, those of you watching this are probably shaking your heads like, what is wrong with Dr. Haynes? His internet connection is terrible. And you're right, it is pretty terrible, but it does serve my needs and only costs $45 a month. So anyway, now you're going to say, hey, I got this fantastic deal, and I don't know, send it to me. I'll deal with it. So anyway, what we're talking about here is quality of service. Why is it terrible and what makes it terrible? So quality of service, or QoS, usually when you put an of in an acronym, you were going to go with a big Q and a little o and then a big S. So QoS refers to how well a network connection meets various criteria. The user experience depends on the quality of service for every link and device between the two hosts. So if I'm on a web browser and I'm connecting to a web server, my feeling about the quality of service varies depending on the whole connection, not just one link by link. But we, networking people, deal with it link by link. All right, second point about QoS. Customers have no quality of service guarantees. If you look at an ad for Cox, my ad for Cox says, I'm going to get up to 10 megabits per second, okay? Cox gives me no guarantees. They give me no guarantees. If the connection goes down, I'm stuck. If I don't get 10 megabits per second, I'm stuck. If I call them and say, hey, I'm only getting 5 megabits per second, they'll say, well, we might send a technician out, but we're not giving you a refund, okay? Consumers have no quality of service guarantees. When you're an organization, on the other hand, you have signed a contract, and part of that contract for a WAN link almost always includes a guarantee. So these quality of service measures we're talking about are typically guaranteed for WAN links, not for consumers though, okay? So first point, before we get to transmission speed, we've been talking about 10 megabits per second. I want to emphasize here, in networking, only bits matter. So we only talk about bits. And sometimes you'll see, like when you're downloading a file, it'll say so-and-so number of bytes remaining. We don't talk about that. We are about bits, okay? So if you're in computer science or whatever, your introductory classes, they might have told you that 8 bits equals 1 byte. And I'm here to tell you it doesn't, okay? In networking, 8 bits equals 1 octet. So what does the word octet mean? Well, actually, it literally means a group of 8. So you've heard of the term duet, that's 2 people, right? You've heard of quartet, that's 4 people, right? So guess what an octet is? It's a group of 8. So I'm not ever going to say byte because it doesn't have any relevance to networking. In computer science, a byte has to do with how much the instruction size of a processor was, and we don't care about that. We're interested in bits per second. So there are times, by the way, that we do group these things into 8. That's what the octet is, and it's often, okay? Octets are often grouped, and we have representations of them using either numbers or hexadecimal form for easier human use, and I'll show you examples later, but just remember, we're all about bits. Bits and bits and bits, and even if I say octets, I'm not going to say number of octets per second, it's still number of bits per second. So, speaking of number of bits per second, transmission speed is sort of the main quality of service measure. Again, it's measured in bits per second, and we increase by factors of 1,000. So kilobits per second is 1,000 bits per second. Megabits per second is 1 million bits per second. Gigabits per second, It's a billion bits per second, terabits per second, anyway, and so on, okay? Get used to these: kilobits, 1,000, megabits, million, gigabits, billion. Every one of them increases by a factor of 1,000, and they're even factors of 1,000. I don't know if you've ever been into storage size, but they call them bibs and a bunch of other crazy stuff, and we're not going to worry about that, okay? We're bits. Transmission speed depends on the capacity of the medium. So a wireless medium, well, I guess that's, open another can of worms there. The capacity of the medium, we'll worry about this stuff later. Capacity of the medium determines the bits per second. The distance you're trying to go also determines the transmission speed, and the processing speed of the devices on the link. So some devices just can't transmit that fast. So transmission speed, again, it's a quality of service measure. It does depend on some things. And on the WAN, you're guaranteed it. On the LAN, just let me note here, transmission speed is typically very high. There's a baseline right now that if you go anywhere, everyone is pretty much all working at 100 megabits per second, which that's really fast, right? That would be like a top-end internet connection, although you can get a gigabit per second one nowadays. So 100 megabits per second is more than enough than most people need. You can run like 5 high-def streams on 100 megabits per second with no problem at all. A gigabit per second is what you would buy at the store. So you would never buy anything less than a gigabit per second equipment anymore. So that's a high transmission speed. Your trunk lines, by the way, on the LAN, and we'll get into why this is later, but those are always higher. And those typically now are going to start at 10 gigabits per second and go up from there. But on the WAN side, you're paying for it. And on the WAN, since you're paying for it, you only want as much as you need. And those go actually really low. WAN links start at 64 64 kilobits per second. So 64K, 64,000 bits per second. Now, if you can imagine trying to run video on that, you're not going to do it. You can actually run a phone call on 64K bits per second, and it's plenty of space to deal with credit card transactions and ATM transactions, like really basic business transactions, work just fine at 64K bits per second. So a business, when they're buying these guaranteed, like it's guaranteed this level, 100% with all these other guarantees on it, they're going to buy as just exactly what they need, and sometimes it's not very much. Okay, so that was transmission speed. Now let's talk the next measure of quality of service, and that's availability. Availability is the percentage of time that the network, that networking link, is available for use. Now, the gold standard on availability is the telephone network. So the old school, like the phone call, beep boop, remember that one? That network runs at 99.999% availability. They call that 5 nines of availability. 99.999% of the time means in a year you have 5.26 minutes of downtime. This is guaranteed, right? You divide that by 12, you're going to get 25.9 seconds per month. So in your contract, it will say your network, this network connection cannot go down for more than, 25.9 seconds per month. So a while back there was a Cox ad, and it was like, hey, order Cox Business Internet because it'll be uptime all the time. And it had this goofy animation of the computers would disappear. It's kind of adorable. But if you actually talk to the Cox people, they tell you the 25.9 seconds isn't just 1 month at a time. They always average it over 2 months and sometimes more. And it's because if anyone has any downtime of 25 seconds, their contract would allow them to have a credit on their contract. So they average it over 2 because those lengths are so short. Now the 5 nines of availability that's pretty much the standard now. And so most internet now just doesn't go down like that. But like I said, if you're a consumer, you're kind of screwed. So availability from the user perspective and really on a given link. So if you're Cox and you're doing a link between, I don't know, any Norfolk Public School building and the Norfolk Public Schools headquarters, there's devices in between. And Cox has to maintain those devices, all of them, to provide more than 99.999% availability, because it's the whole link that they're responsible for. So this is a hard business. Availability is something we worry about. All right, next up, error rate. Error rate is the percentage of messages damaged or lost in transmission. Error rate depends on the media. So wireless has a higher error rate typically than wired, and that has typically higher error rate than fiber. Interference affects your error rate, and the distance affects your error rate. There are some transmission methods that correct errors, and we'll talk about that in the next module. If there's substantial error rates, it increases network traffic, and it can sometimes cripple a network because of retransmissions. So anytime you're transmitting something and it doesn't get through because of an error, it's going to be retransmitted, and you're basically wasted that network space. So error rate. All right, next up is latency. Latency is the amount of time that a message takes to reach its destination. Latency is typically measured in milliseconds. Latency on a LAN connection is typically less than 1 millisecond. In fact, it's less than typically 1 microsecond. Latency over a WAN, so the bigger connections, depends on the distance. So if we're talking about latency here from Norfolk to Los Angeles, you're looking at about 45 milliseconds of latency just to get there. Okay, so we're talking latency here, and it also depends. That would be at the speed of light. Latency is also affected by the processing speed of devices along the way. So those of you that are gamers know that the ping matters, and ping is the, lamer word? You gonna call it lamer? Ping is what the uncool people call latency. Latency, now you're a networking professional and you're gonna call it latency. Ping, by the way, is round trip time, and latency is one way, but yeah, whatever. Okay, so latency. Latency is super important also for voice. So when you're making a phone call or video call, well, video too, latency really matters. You see that sometimes when you're watching the news, that you'll have a situation where, someone's talking to a remote reporter and they're like on the other side of the world. It's like, hey, how are things going in Iraq today? And you'll see the reporter kind of looking around or thinking, and then they'll say, oh, hi, and start talking. The distance or the difference in time is latency, because it just took that long for the reporter to hear what was going on. And those of you that are gamers know this too, kind of intuitively. For example, while you're playing a game against someone, that the moment they click, the fire button, that command is going to take a certain amount of time to get to you, same as your fire command takes to get to the other person. And so you like a really low latency on your computer between especially your computer and whatever server you're connected to. And usually you can kind of kick someone's butt if they're not. Am I supposed to say that? I can't say that on video, can I? All right, we'll just keep going on. All right, so gaming, latency is a big issue. Those of you that aren't gamers, yeah, it's about voice and video. So the next one is kind of weird, and it'll come up again, so don't worry about this one too much now, but I want you to be aware of it. And this is the final quality of service measure this is again in the contract. Jitter is a quality of service measure that's a variability of latency. So we have situations, especially when a link is congested. Remember we talked about those trunk lines? And you can think about the trunk lines like traffic merging onto the freeway. If the traffic merging into the freeway is sort of merging smoothly and evenly, like there's space for all of it, then traffic just keeps moving at the same speed. So if I'm going from here to Richmond, and I can count on that there's not any sort of congestion in my, quote, traffic network, I'm going to get to Richmond, let's say, an hour and a half. I'm a slow driver too. I'm old, right? I mean, you can see that looking at me. I'm old, I drive slow. Those of you that get there in an hour, go for it. So my latency from here to Richmond is an hour in normal circumstances. If there happens to be a lane closure, let's say, and now the traffic can't merge smoothly, what happens is that congestion builds up and then my latency increases. So in that situation, my latency has changed. This same thing happens on networks. So you'll have times, and you might be experiencing this now, that someone else in your family is on your network connection, and now everything has slowed down. I guess your family, roommates, whoever. If a bunch of people all of a sudden come onto your network, they're competing for that shared line, that trunk line, and now everything is going to slow down. So your latency changes. Now, if you're a WAN carrier like Cox, Verizon, etc., you are expected to manage your network capacity well enough that the latency doesn't change from time A to time B. So not only do you have a penalty for violating the latency quality of service, you're also going to have one for violating the jitter quality of service. The main reason for the phone system to worry about jitter is it makes your voice break up when you're talking. So if someone's talking and it kind of goes, that's the jitter. That is that there's been a space added into the voice. So we don't want that to happen, and that's why it's a quality of service measure. So that was it in terms of, if you're going to have it written into your contract. I want to emphasize right now here, though, that users don't experience the quality of service measures directly. It indirectly affects them. So a user thinks about throughput, okay? So if, thinking of my 10 megabit per second connection, man, if my son has to download a video game update, geez, those things are like 60 gigabits long. And at 10 megabit per second, I gotta tell you right now, I can run like 2 high-def video streams simultaneously. So for my purposes, it's not that bad. But when this poor guy has to wait overnight to download an update, he is not happy about his throughput, that quality of service. So throughput, generally speaking, especially because of congestion on shared links, is lower than the rated quality of service. So if 2 people are downloading an update at the same time, each one gets half of that amount of throughput. So throughput is related to transmission speed, but it's part of the overall system that the users are involved in. Response time is kind of like latency. So if I send a request, how quickly do I get my response? Well, latency obviously is going to affect it, but it's also affected by the response time of the other host. So, if I make a web request and it's slow coming back, it depended on the other host also, not just my latency, okay? So, it happens to gamers too. So that's kind of what latency is about. Downtime is kind of an indirect measure of the reliability and the error rate one, but it's not just about the link now, right? Sometimes the host will go down, and there's also multiple links along the way. So when the user's network is down, it's just downtime. But the reliability are a specific measure. Maybe certain links are up, but if one link is down, then everyone has downtime. So we need to know the direct stuff. They need to know the indirect stuff. So that was it for Module 1. We just finished off the quality of service video, and you can tune yourselves into Module 2, and you'll see me soon. Bye.